Demystifying infrared missile guidance, how they find targets. Infrared-guided missiles are an important part of air defense weapons in modern warfare. Many people are fascinated by these high-tech tools, which have made them wonder about the mysterious idea of locking onto fighter planes. In this in-depth look, we go into the inner workings of infrared-guided missiles and debunk the myths about how they find their targets. The essence of infrared guidance. Shoulder-launched anti-aircraft missiles are guided by infrared guidance, a cutting-edge technology that employs infrared signals for pinpoint targeting. This section explains the procedure by dissecting the FIM-92 Stinger missile's mechanics. The role of infrared seekers. Imagine the front end of the launch tube of a Stinger missile. It has a clear polyethylene cover that breaks apart when the missile is fired. This clear front is part of the missile seeker, which needs infrared signs from the outside to start up. As the rocket goes up, the shooter uses a parallel optical sight to the launch tube to find targets in the air. The infrared signals picked up by the missile's infrared seeker match the ones picked up by the missile's visual sight. A symphony of signals. When turned on, the Stinger missile makes a weak buzzing sound. This is caused by the missile's infrared seeker converting infrared signals from the sky background. A steady sound means the sky, while a change to a higher-pitched buzz means the sensor has found a bright infrared emission source within the field of view. This change in the signal's voltage tells the user that an aircraft's infrared signal has been spotted. The path to homing. As long as the high-pitched buzz keeps going, it means that the target is still in the range of the infrared tracker. At this point, the shooter can start the missile's launch. Contrary to what most people think, the missile doesn't lock onto the target in the usual way. Instead, it constantly adjusts its path based on the strongest source of infrared light in its field of view. This process, called homing, includes a lot of complicated calculations and changes that keep the missile on track to hit the target. Decoding the code disk. Learning about a critical part called the code disk is essential to understand how missile navigation works. This part is vital for getting the missile to its goal. The code disk's dance. The code disk spins at high speeds when the missile seeker is functional. On the disk's surface are gratings that intermittently block the light signals received by the infrared sensor. The pattern of these interruptions determines whether or not the infrared sensor detects the signal. Navigating with precision. The code disk sends out a steady signal pattern when the infrared target lines up with the missile's flight path. But when the object moves away from the center of the field of view, the pattern changes into pulse signals. This change lets the missile's control surface servo react to the signals from the code disk and change the missile's path. This complicated teamwork ensures that the target stays in the middle of the missile's field of view, making it possible to track it precisely and eventually intercept it. Beyond the locking myth. As we explore the world of infrared-guided missiles, we come to a deep realization. The idea of locking is more complicated than we first thought. Even though the term makes the process easier to understand for people who aren't experts, it doesn't capture the complicated dance of signals, adjustments, and exact calculations that happens when a missile is guided. The real point of infrared guiding is to keep looking for the brightest infrared light source, which is the epitome of accuracy and planning. Elevating air defense capabilities. As we learn more about how infrared-guided missiles work, we can see how elegantly they are made. These precise instruments are a great example of how cutting-edge technology and strategic thought can work together to help people solve difficult problems. In a time when technology is changing quickly, understanding these changes gives us a better understanding of current defense systems' complexity. Thanks for watching.